coming to my presentation. I teach a history class, Technology and Human Outcomes, and one of the 10 classes is on climate. So I put some more information into it and to present it to everybody. Just a little background for me. I really started focusing on climate or trying to understand climate when the town of Falmouth put a 1.5 megawatt wind turbine 1,200 feet from my house. The town manager at the time wanted to be the first one in Massachusetts to put up these echo crucifixes, as I call them, as other people call them, irregardless of breaking state guidelines on noise or making people sick or causing house values to plummet because of wind turbines in the backyard. So I started focusing or trying to understand what was going on with wind turbines. In any event, the town of Falmouth was sued. This was a big case. I think it made national news. And the 2 wind turbines have been shut for a couple of years. And the town's trying to figure out what to do with this, $15 million mistake and how to get rid of them. And, the thing about wind turbines and why everybody's talking about putting them in the ocean is in Europe they have regulations. They can't be a mile from somebody's house. And people get sick if it's closer than that. So something about wind turbines, and that's how I got started. Let me start going with the class. I just thought I'd add a little bit of levity if you could read this. Hope you can read this. I'm not going to read it for you. I like forget mowing the lawn anymore. Just let it die and then paint it green. And clothing optional Fridays because it's going to get so hot. Okay, so I'll skip the agenda. I'm not going to be able to get through all this. But what I want to start with is what constitutes a science paper. I know a lot of you folks are in science. And the science papers these days have gotten really, really bad, including the IPCC, which is the UN Climate Change Program. And then we'll go into, things about facts that really were misstated. So we'll talk about the climate. Okay, we had a program in lifelong learning independent group. Somebody came to lunch and said, increased frequency of tropical storms, hurricanes, and wildfires, ice sheets melting, rising sea levels, crop failures, droughts, grasslands turning into desert, et cetera, et cetera, et cetera. So I like to cover these, and these were stated as facts, but you have to ask why do people misstate facts as true when they're not true? So a little more levity. Not everything you read in a blog is true. The whole climate change scare is all about models. So I like this one in particular. We put data into dozens of different climate models and ignore the ones that make us look wrong. Trust me, this is what's going on. Okay, so what's the science paper? And maybe somebody could talk about this a little bit. So what's the criteria for compliance with science? Because we're talking about science of climate change. So this is what this is all about. And this is a Professor Scott Armstrong at Wharton School. He came up with this. And you don't even need to be a scientist to look at a paper and say, does it meet these 8 things? So for example, should we test multiple reasonable hypotheses in a science paper? Yeah, nod your head. I mean, it shouldn't just be one thing. We should look at, what are the possibilities? Should there be useful findings? Something that we can use out of the paper. To write a paper with no use is not that useful. How about full disclosure of methods, data, and other relevant information? Yeah, do you remember cold fusion? We're going to save the world with cold fusion, and everybody started retrying those experiments and couldn't get it to work. You can't retry things if you don't have the data. or the methods. How about a comprehensive review of prior knowledge? How did you get here? What happened in the past? Valid and reliable data. Everybody remember the Lancet paper that said hydroxychloroquine kills people? There was no data, it was made up. Lancet was happy to publish made up data. So much for our scientific journals. Valid and simple methods. Everybody knows what Occam's razor is. Things should be simple. Experimental evidence provided conclusion consistent with the evidence. Okay, everybody agree? I mean, this is what makes a science paper. Okay, IPCC, we always hear about the IPCC. They violated all 8 criteria. They don't share the data. They don't share the methods. They don't look at the past. Actually, they changed the past. So this is IPCC, not really a science paper. And Professor Armstrong answered the following question. Only a fraction of 1% of the papers published follow the scientific method. And the reason is no one asked them to. It's all about publishing, and you can publish crap these days. You can publish made-up papers. There were some psychology papers made up, and then the poor professors got fired for making up papers that got published. I think one of them was about monkeys. So why do they do these papers that are not scientific? They get money for it. They get coverage. They get to be on CNN. A lot of different things. But those are the reasons. But you can do this test. And Professor Armstrong just had business school people look at the papers and come up with it. You didn't even have to be scientists. They just had to say what's in the paper. So that's what all this, modern science is about. You have to be, really show stuff these days, but most papers don't. Okay, so a little bit about consensus. Everybody says 97%. I heard 99.9%. So I just wanted to share some examples of past consensus. Remember when the scientists said the sun and the stars revolve around the earth? That was consensus. Was consensus right or wrong? How about the world was flat? We look at Harvard very highly, and maybe some of you have been to Harvard. But a consensus of Harvard graduates said that witches cause crop failures. How about stress and not bacteria cause ulcers? You realize how many surgeons, the surgical population lost billions of dollars a year because they used to do surgery to get rid of ulcers. And what happened? One doctor, I think in Australia, worked for 15 years to prove that H. pylori causes ulcers. And I got it traveling in Spain. Then I read recently that half the Spanish population has H. pylori. So now I know why I got it in Spain. Okay, so that's what consensus is. There's no consensus in science. Science is hypotheses, testing, results, proof. That's what science is, not voting. So, yes, science is proof. Anyway, so 97% was somebody analyzing a bunch of papers. Nobody voted for this. There was no vote. And they measured the papers, and eventually she admitted that there were mistakes in her papers. But somebody else went through the papers, and I'm not going to read all of this. Some of them implicitly accepted consensus view, but they didn't declare it. They were just talking about impact. So 97% comes up with papers that are related to climate, but have no agreement that humans cause major climate change. And you can kind of read this. Another rebuttal. 66% of the abstracts expressed no position on human-caused global warming. 32% endorsed it, and 0.7% rejected it. So, if you re-examine the papers without fog glasses, you come up with different results. Another rebuttal. It turns out that Cook analysis in 2013 dropped 75% of the papers that didn't meet his goals. He dropped 33 of the 50 most cited papers. So if you only looked at explicit endorsements, it would be 8%, not 97%. I just want to give you can do your own research. There are rebuttals. There's all kinds of stuff, blogs on the internet. But these are professors that went back and looked at the papers. By the way, those researchers, like the scientific method, did not even tell the world what papers they looked at. They hid their data. Anytime anybody wants to hide data, you know there's something fishy going on. Okay, anybody disagree about this? July 2008, 31,000 U.S. scientists signed a statement denying alarmism. Just recently, 500 scientists sent a letter to the UN saying there's no climate emergency. By the way, not one of these scientists say there's no global warming. You know, there is global warming. We could look at temperature records. They have gone up. But how about in the past? Were they high in the past? Or it's just the highest the world has ever seen? So, you know, we have to understand, and you can play tricks with graphs to see if things are going really fast or not really fast. But anyway, so yes, the world agrees that there's climate change. The world doesn't necessarily agree that it's CO2 based, which is what some people are saying. Anyway, so just a question, do you guys still believe the 97% of scientists believe in AGW, or is it questionable? I'm just going to go through this pretty quickly. 50 years of promises. You know, Paul Ehrlich said that 65 million Americans would perish in the Great Die-Off. These are all futurists. Newsweek fell in line and issued a cover story about global cooling. And why did they do that? Because we were cooling back then. That was a period of time where the US was cooling. So you have these, you know, promises, we're going to freeze to death, we're going to starve to death. 1988, scientist Ted Danson said we only had 10 years to live because the oceans were going to die. I have a class on energy, and there were promises of oil. You know, we're going to run out of oil. Every decade, there's another promise that we're going to run out of oil. We haven't run out of oil. 1986, climate scientist James Hansen went to Congress and said we would heat up by 4 to 6 degrees by 2020. And then in 1999, he said, oh, the world is cooling. We're in trouble because we're cooling. This is a scientist. This is a guy from NASA. And you know what he did to convince Congress that the Earth was warming in 1986? He turned off the air conditioning in their meeting in Congress and opened the windows to let the hot Washington air in. So nice trick. It was effective. The poor congressmen were sweating and didn't understand why. Yep, 1975, the world will freeze. 1980 was Michael Mann's hockey stick. The world's getting warmer. By the way, Michael Mann never shared his data either. 1990s, the world has 18 years left to live. Actually, I think I recently heard a politician say we only have 12 years. Polar bears will die off. Everybody's going to be underwater. Climate change because the world stopped warming in the 2000s. Prince Charles, we have 96 months for the Earth to survive. Anybody want to tell me what happened to all these? Anybody want to unmute themselves that these things come true? These people are called alarmists. That's how you raise money, is by being an alarmist. I'm going to skip this. Okay, so let's open it up. I know I asked folks to watch Planet of the Humans. It was about wind turbines and solar panels. Anybody have any comments on the movie before I state my comments?
I did.
Shelly,
I'm sorry.
Shelly, I watched the movie as well, and I sent the link around, thanking Carl for showing it to me. That refutes what was going on. So, as you know, as much as there's alarmists and there's controversy, there's still even controversy about the data that was presented in Planet of the Humans.
Okay. Sure. There's controversy with everything. Joel, you had something?
I only saw the first 2/3 of it, but basically what I was seeing was a lot of people were doing things, and it wasn't as clear cut as they thought, and you got the wrong impression by looking at it. You know, it was clear, they were helpful, and yet they weren't. But there was nothing about the fact that there isn't a problem that we're facing.
My take on the movie was, you know, solar panels and wind turbines are very expensive, unreliable, are pollutants with poisons like arsenic in solar panels. They're not recyclable. They cause children going in mines to get cobalt. There's all kinds of bad things about it. But the worst part of the movie was at the end, they said, oh, there are too many people. So we really don't need these. We just need to get rid of the people. So that was the message I got from the movie that I totally reject. But certainly I can accept the fact that these things are not good for people. And I mentioned earlier that nuclear would be a much better approach than covering all of California with solar panels. By the way, do you guys know what's going on with California with their green initiative? Anybody want to chime in?
California is burning up. California is burning up.
I have a slide on burning up, so we'll get to burning up in a minute. And I'll tell you why it's burning up. Peter, you have anything on the brownouts in California?
No, thank you.
Yeah, so California went to 30, I think it's 36% green energy. And guess what? Sun goes down at night and they didn't have enough electricity to cover the air conditioners. It's hot in California. You know, there are regions that are deserts. They used to buy electricity from Colorado and Arizona, but guess what? It was hot in Colorado and Arizona, so they didn't share. They didn't sell electricity to California, and they have brownouts. What countries in the world have brownouts? Any first world countries have brownouts? You know, what if you're on home dialysis and you lose your power?
Yes, we have brownouts here in Lexington.
Yeah, it's called a tree falling down on the wires. That's not a brownout.
No,
Although
it's not enough generating the distribution capability.
Yeah, I mean, this is India. I had a team that worked for me in India. And I go to the office in India and I see everybody has a laptop. I say, why do you guys have laptops? And all my engineers in the US aren't allowed to have laptops. They have to have desktops. And then after an hour, I found out why they all have laptops, because the power goes down 3 times, 4 times a day. So third world issues. This country cannot afford to become a third world country. California has electric rates higher than everybody because they're buying expensive electricity and they're subsidizing it. So, and they want to go 100% green. So what do they do at night in the summer? Guess what? In the summer, the wind doesn't blow that much. So you have less wind energy. You have no solar energy at night. What's going to happen? Your guess is as good as mine, but it won't be good. It won't be good.
Right. One point I want to make is, like, even if you didn't have these problems of pollutants, let's say, with solar, it only contributes 2% right now of our needs. It really just can't do the heavy lifting. So even if the cost was free, it would not solve the problem.
Correct. I'd rather take CO2 than arsenic any day. Okay, and we talked about this. Plus, wind turbines make people sick. Okay, so how do we tell the history?
Can I ask, what is it about a wind turbine that makes people sick? What kind of symptoms do they get?
Okay, so wind turbines spin around, they make around 3 hertz pressure waves. So yeah, any machine makes noise, audible noise, as well as not audible noise. And what causes people to get sick are the pressure waves. So the way I like to describe it is, imagine living in a drum and somebody's banging on it 3 times a second. And what do you get? You get patients, and this is all over the world, not just in Falmouth, but all over the world. Patients get nauseous, they get tinnitus, which means they start hearing things in their ears, and it's not immediate. It takes a few months for your body to get this thing. They feel heaviness, they can't sleep, they can't concentrate. And what's the cure? What's the cure to get rid of these symptoms, except for tinnitus, which is permanent? They leave their homes and they go somewhere else. So people have been forced to sell their homes for a loss because they can't live there anymore. People have been forced to leave their houses. I know neighbors that were forced to sleep in the basement because they didn't get those sensations in the basement. So this is wind turbine syndrome, and you can look it up. There are physicians all over the world. That's why in Europe they said 5,000 feet from a wind turbine. You can't put a wind turbine at 5,000 feet close to a house.
Can you cite a study that we can look up? Can you cite a published study we can look up?
I can send it to the link to the group. Let me make a note to send published studies.
There are cases, though, where wind turbines in a particular locale make sense. Like if you drive out west and you see these high ridges where they put an array of wind turbines, it seems to make perfect sense to make use of that energy source. No?
Yeah, on top of a mountain where there are no electric wires, you can put a solar cell and a battery, or you can put a wind turbine. The reason wind turbines and solar panels cost so much it's not just the material, it's not just the $5 million for the turbine. You now have to start running high voltage electric wires, 100, 500 miles. So if you look at West Texas, where they have a lot of wind turbines, the cost of running these electric wires, because the turbines aren't near the cities where people need the electricity, you have to run all these wires, very expensive. So now you have the capital cost of the wind turbine, the billions of dollars in electric transmission lines, and the gas power plants for when the wind doesn't blow. So you're talking about, and you can put a gas fire plant close to the city because there's not much pollution that comes out of a gas fire plant. You don't need to run all these big electric wires. So you're talking about a huge cost for all these things. That's what makes it so expensive. And you double, triple. I think Germany has triple the electricity cost of the U.S., which means any business that needs electricity will go somewhere else where the electricity cost goes. All right, so a little bit about historical records, tree rings. So we don't have records all around the world for what the temperature was. So you have to use proxies. And this is, a lot of scientific papers talk about these proxies. Tree rings, wide rings show faster growth. Ice core drilling, so you can use carbon-14. Carbon-14 is a result of cosmic rays. You can look at the, microscopic organisms that were there. Are they in the core? Are they bigger or smaller? It gives you a proxy for temperature. And then fossil records. So, was this the hottest period ever seen on Earth? True or false? I think Joel says, shaking his head no.
False.
Well, CO2 increases before the Earth warms or after the Earth warms? Okay, so
I find what you're saying is sort of irrelevant. Today, we know that there's climate change. We don't have to look at tree rings anymore.
Well, you do, because you have to know, does CO2 cause it or does something else cause it?
No, we don't. We know. We know what causes it.
So tell me, Larry, what causes it?
What? CO2 and methane are the two biggest problems.
All right, so why don't you let me finish my presentation? And then we can discuss it afterwards.
Okay, but
Okay.
I think the question of this, did CO2 come before or after, is a false dichotomy, since it seems to say that if it came after, it couldn't have been part of the thing. But in fact, CO2 may well have amplified a solar cycle.
Could be. So let's talk
Not
about.
not only that, but you've ignored another hypothesis, and that is
Yes.
that earlier warmings might have involved some different mechanism. We're worrying when we're talking about CO2 today. We're talking about this particular warming cycle, and the others are all very interesting. But it's conceivable that it. I mean, not that anybody's come up with a theory, but it's conceivable that other events, made a difference. On the flip side, for example, an asteroid, which caused some of the great cooling.
Yeah, I mean, we know there are all kinds of causes for cooling. I'll show you some slides on, what the current models try to do with cooling, like cloud cover and stuff like that. But
Shelly,
ahead.
going one step further to follow on what Mike said, I think, put it in perspective, you have to compare climate change, and I'll use that term generically, today in what we're experiencing in our lifetimes in our current environment, to because we're blaming, if you will, CO2 and humans, to the climate differences that were experienced pre-industrial age, almost as back far as we can go through the studies of Antarctic ice and other historical artifacts to understand how this differs from the climate variations that have been discovered during those times, to really understand what's happening.
Sure. So, I mean, here's a big mystery. Here's a tree ring history of, last 2,000 years, and there wasn't humans weren't causing CO2 in the medieval warming period, which was as hot as it is today. So human-caused CO2 did not make the Earth get warm. There wasn't that much CO2. We weren't pumping out, burning, oil. We were burning trees and dung and all kinds of other stuff in the Middle Ages. Climate change happens, whether or not we have CO2, whether or not we have asteroids, volcanoes, cloud cover, cosmic rays. There are a lot of reasons for climate change. And by the way, what causes the Earth to warm is the sun. That's the biggest heat driver. But anyway, I just wanted to share that, and I also wanted to share this slide, going back millions of years. So we used to have lots, 6,000, 7,000 parts per million of CO2. Remember those fossils of those giant ferns? There was so much CO2 in the environment that all these plants grew like crazy. And that made the oil that we burn today, was all that high CO2, high plant growth. And it fell, CO2 fell. But interestingly, when the temperature rose again 300 million years ago, CO2 seemed to lag it. And temperature fell, but CO2 went up. So, there are a lot of questions. Historically, if you look at history, you get a lot of questions on, CO2, does it correlate to temperature? It doesn't historically. It only seems to correlate recently, but it doesn't correlate historically. And correlation is not causation. Let's look at CO2 in the atmosphere. Does CO2 act like a down blanket? Anybody have an idea of CO2 acting like a down blanket? If you double the CO2, you double the heat magical properties. Dr. Royce Spencer is one of these researchers. And he likes to quote Al Gore saying, we put 70 million tons of CO2 in the atmosphere, but Mother Nature puts 24,000 times that in water vapor every day. Water vapor is the thing in the atmosphere that drives a lot of our climate. And it's called clouds, but it's also called water vapor. Back in 1971, we had NASA scientists that talked about carbon dioxide in aerosols. So back in 1971, NASA said that if you double CO2, you get a 0.8 degree change, but it won't go more than 2.5 degrees. So they're talking about absorption factors. Every element has a spectral absorption factor. So the question is, why did NASA scientists back then seem to think there was a limit to CO2? What changed? So here's the absorption factor, black body radiation, all the heat we have. Here's visible light on the far left. CO2 is only absorbs as a down blanket. CO2 only absorbs about 8% of the spectrum that comes out. 8%. Now, if you triple this, if you put enough CO2 that it absorbs all 8%, and then you add more CO2, it won't absorb anymore because you already have enough CO2 to absorb 8%. So this is the science of CO2. If you put water vapor here, it would be a bigger factor in absorption. Water vapor absorbs a lot more wavelengths. Any questions on this?
It's not simply the CO2 absorption, it's the re-radiation from the CO2. It's a much more dynamic
Yeah, re-radiates.
thing than you're describing.
So it re-radiates back to itself?
Back to the Earth.
Back
It re-radiates in all directions, but that includes back to the Earth, which actually can, if you think of the atmosphere there, it actually subtends a tremendous angle of that. So at least half.
Okay, so if you cover the Earth with CO2 and absorbs all 8%, so it keeps absorbing 8%. You add more CO2, it won't absorb anymore because it already absorbed all 8%. It's still, you can radiate it, but it still absorbs that. So
Have you ever studied the atmosphere of Venus?
no, I haven't.
Venus's atmosphere is almost entirely CO2. It's very high density of CO2, and the Fahrenheit temperature on the surface of Venus is about 800 degrees Fahrenheit.
Yeah, it's also very close to the sun.
Not much.
Very close to the sun. And Mars,
That's not very close. That's about 3/4 of the distance that we are from the sun.
Yeah, I guess
If you call that
800
very
degrees
close,
Fahrenheit?
you're talking Mercury.
every
You know,
million
you're
miles.
using
every
all of
million
the same
miles.
arguments that we hear all the time, and it's kind of aggravating to hear this kind of just brush aside all the very criteria that you stipulated are necessary for a science paper.
I haven't seen anything else that talks about CO2 absorption. It's not a miracle particle, except for making plants grow. It's a miracle because it makes life on the Earth. But I haven't seen anything beyond the 8%. It doesn't radiate, re-radiate. No experiments have shown this. Hate to say that. There have been no experiments about that. This is the model that we're talking about. The sun comes in. It's absorbed by the atmosphere. It goes down to the Earth, absorbed by the Earth. It evaporates. There's thermal goes back up, gets absorbed by clouds and CO2. It resends stuff down. It goes out into the sky. This is your basic model that IPCC uses, and they try to fit all this stuff on it. There's a lot of validity to the model. I'm not arguing against the model. But I have one question. Why don't IPCC factor in the heat from the sun? They make it a constant. But we know the sun goes through cycles. It goes through 11-year cycles. It goes through 100-year cycles. It goes through 900-year cycles. They don't factor any solar cycle. So it's kind of interesting that we have the Earth is warmed by the sun. You know, maybe there's some internal volcanoes that warm the Earth a little bit, but mostly Earth is warmed by the sun, yet the models don't factor the sun. And we know the sun is variable. So
Let me go back to this model that you just showed, the slide.
I'm sorry, Mike, I didn't hear you. Could you speak up?
Yeah, let's go back to the slide that you're showing. All right, there's nothing specific about that, but you've been focused so much on the 8% that of the spectrum of the solar spectrum that's the CO2. But if you look at the part where it's being re-radiated down, that's a sink for the heat that could be radiated down by the CO2. And therefore the numbers that you're using don't account. Now I don't know quantitatively what it would be, but your model throws away the idea that the radiation down from the CO2 is being absorbed by the Earth. And therefore,
I'm not questioning. Sure, some CO. Wait a second, Mike. Some CO2 radiates down to the Earth, but there's like 1,000 times more water vapor that radiates down to the Earth. CO2 is small compared to water vapor, so you can't double CO2 and get a little bit, you know, the 8% that it absorbs to act like water vapor that absorbs much more of the spectrum and radiates much more down. You know, you need to compare what's the big boy in the room. The big boy in the room is the biggest part of this picture, which is the cloud. Water vapor is the big guy that absorbs all the radiation. It also reflects radiation.
There's another number that's missing, and I don't know what it is. If you're just talking about it in both cases, the re-radiation and things and that sort of thing, it has to do with the efficiency factor. What's the efficiency factor of the re-radiation of the water vapor?
Okay. Yeah, I don't have the answer for efficiency factor.
Well, that's a key thing as to whether water vapor as opposed to CO2 is important.
No, excuse me.
Because other people really have looked at the water vapor issue for decades.
So if solar cycles are responsible for the warming we've seen since the start of the industrial era, why is it that the upper atmosphere is cooling while the lower atmosphere is warming? That would seem to be consistent with there being CO2 that's preventing, keeping more heat down closer to the Earth.
Okay, maybe, but maybe it's more water vapor doing that. I don't know. Let's keep going. Good question. Models. We talked about models. So this is the CMIP5 models. Observations. You can see the observations. Yes, we're going up. It's been how many years since? 25, 45 years since 1975, and these are the models. The models are very scary, and they don't, except for the Russian model, they don't actually follow what we observe. So something about models that are designed, I think, to scare people because they're not close to reality. Now, normally when you do a model, you test it against reality. I don't quite know why they produce these models that don't work. They don't work backwards, and they don't work forwards either. And what does IPCC use? They take kind of an average of all the models, and that's what they publish. So just give you an example of the models. By the way, all these models are secret. They don't share their algorithms. They don't share the data. They just, this is what it is. Here's my model, and add it to the list of models. The art and science of climate model tuning. If you create a model, shouldn't you tune it to reality, or should you tune it to what you'd like to see based on specific goals or cultural identity? So models are to be kept in the anticipated acceptable range. This is how you would design a model for identity or for acceptable range. I mean, this is what's going on with the modeling business. This is a new one. We have a new model coming out. I just wanted to share. There's a lot of research that goes into these things: chemistry, aerosols, carbon cycle, land use, geoengineering, scenarios, impacts. There's billions of dollars spent on this thing every year. The MIP, cloud circulation. A little bit about solar cycles. You know, this is the 11-year cycle. So somebody's forecasting another minimum like the Maunder minimum, where crops failed and people couldn't eat, coming up. This is NASA predicting very low solar activity. So I just wanted to share, you know, what happened in the 60s, modern maximum, lots of sunspots, lots of solar activity, and we're coming down in terms of solar. By the way, this is where people thought the Earth was cooling. 1970, the solar went down, then it went back up. So solar cycles do change, and the amplitudes do change. But that's not factored in any of the models.
So
All right, there's a lot of stuff. I know we had 2 hurricanes for a while. There's one category 3 coming up. Hurricanes increasing in number and strength as the Earth warms. Anybody have a thought? I mean, we're told we're going to get more hurricanes. How about tornadoes? Okay, so this is the global major hurricane frequency, 12-month running sums. All hurricanes and major hurricanes. So it doesn't seem to correlate with CO2 rising in the atmosphere. There's actually a science for this. So hurricanes and tornadoes are caused by differences in temperature, right? You have a high and a low area in temperature. You get thunderstorms. You get tornadoes. You get hurricanes. As the Earth warms, there's less of a temperature difference. So we know the Earth warmed a little bit over this period, and there's less of a temperature difference between cold and hot, so you actually have fewer hurricanes. So it's kind of a scientific reason for having fewer hurricanes. And also a scientific reason for the same reason, if the Earth warms, there's less of a difference between the Arctic and the equator. You're going to see less of these gradients. So just some examples. The history of hurricanes go back to 1850s. Here's tornadoes. 1954 EF1 category tornadoes, 54 to 2014. Hasn't gone up since 1954. How about F3 plus, the really terrible, huge tornadoes that killed hundreds of people? Doesn't correlate with CO2. Correlates with a warming world a little bit, where we get less of this wind shear. And tornadoes are terrible. I'm happy at it. We don't live in Tornado Alley. But so these are just facts coming out of the U.S. government, coming out of record keeping. So not so bad. It's nothing to be alarmed about. Hurricanes, you know, going crazy. How about daily highs for the last 14 years? So I think, you know, that's why we got the name global warming instead of global climate change instead of global warming. It was like a little hiatus, the daily highs. How about annual heat wave index, 1895 to 2015? So a heat wave is at least 4 days of temperature that normally doesn't happen. Any
Shelly, you can make the argument that the heat data you're showing is relatively short window compared to history, and I think that's just needs to be stated.
Yeah, we probably only have records going back 135 years, but we know that CO2 has been going up since the Industrial Revolution. We've been burning oil, then gas, and so a lot of this temperature goes up because of CO2's correlation. And I just want to show things that don't seem to be correlated. We know what happened in the 30s. That was the Great Depression, the heat wave. people leaving the farms because it was too hot to grow crops. That was a disaster for this country. Certainly, heat waves like this are a disaster for any country. But it doesn't seem to correlate, right? I mean, every year there are records for cold and records for heat. But here's a heat wave. Okay, I'm sorry?
Can I ask, how about data that does show a correlation, like Hansen's data?
Not on heat waves, not on.
No, I'm looking at global and global surface air temperature change from 1880 to 1980.
Yeah, we know the temperature went up. We know that went up like a half a degree or whatever. Yeah, nobody's denying that. Nobody. Okay. That's what correlates to CO2.
Yeah.
Not heat waves, not hurricanes, not tornadoes. We know the temperature went up.
So you're not denying global warming then, or are you?
No, of course not. I like it. I like it.
No, I don't care if you like it or not. I just want to know if you think it's true or not.
Of course, there's no such thing as a denier. Everybody knows the temperature went up.
Okay, very good.
Okay, no such thing as deniers. Forest fires. Are they increasing in number and strength? We know California is burning down, right? I don't know if you know that in the old days, they used to have logging. And by the way, it's not just California, it's the federal government has royally screwed up on forest management. So if you eliminate logging and logging roads and you don't clear dead trees and brush, what do you think happens? Lightning happens, electric failure happens. Have there never been forest fires in the world? We know from fossil records and stuff that there are always forest fires. So is forest fires man-made because of CO2 or man-made because we don't clear the dead brush away?
Yeah, I have a question about this forest fire issue here in California.
Sure.
Isn't the real issue that most of the vegetation in California is not native?
Settlers
have brought in the vegetation. It doesn't really belong there, and so it's contributing to the fires.
It could be, sure. Why not? We know that California is a desert. It goes through dry spells. There are bugs that eat trees. Trees die everywhere. They die in my backyard. They die in California and they fall down. The question is, what do you do about them? Do you let them keep going up as fuel, or do you take them away? Fires caused by vandalism, lightning, et cetera, et cetera, et cetera. 2019, blood's in your soul. It's morality, now wildfire emergency. Guess what? In 2016, he vetoed a bill to clear trees from overhead electric wires. Finally passed in 2018. You have to manage. You have to manage forests. You have to manage environment. How do you get rid of deadwood? There used to be biomass facilities to burn deadwood. They would have logging roads and pull all the deadwood and burn it. But they, because of emissions, they were all shut down. Actually, because of gas. Natural gas was so cheap. It was too expensive to drag the trees out of the forest. Okay, timber harvesting in California. 1957. Private and U.S. Forest Service. So what happens when you stop harvesting trees? They burn. They burn like they burned for thousands of years. So IPCC 13, this is a Heartland. They have an annual conference on climate. So this was a presentation from Heartland. So this was somebody from, I think, Nebraska. Decrease in harvest, increase in wildfires. Very, very, very large correlation.
Well, sure, because look at the extreme. If you cut all the forests down, there won't be any forest fires.
You don't have to. It turns out you don't have to cut all the forests down. You have to have roads so that the fire people can get in there and limit it. You have to cut the dead trees and brush so they're not, fuel load, because live trees don't burn very well. It's really the dead stuff.
Look at what's going on. Oh no, look at what's going on in California now. Live trees are burning. Live trees are burning very well. The roads are not stopping the fires because.
Yeah.
because
By the way, the live trees burn when they have all this dead brush underneath them. That burns.
no, there are such things. There are crown fires, for example, or there are, or there are sparks that are being carried by winds to
Yes.
reset the
Yes.
fires. It isn't just that.
All right. Anyway, so here's a history of again 11 states, western states, in 100 years. In the blue, that's when they had all the grazing and logging roads, and then that kind of ended in 1980, and we had wildfires. So you can burn them in a electric plant, or you can burn them naturally. This is what happens to forests. By the way, England gets a lot of their electricity by burning South Carolina trees. I don't know if you know about it. They shut down their coal plants and they developed these giant pellet stove plants for electricity. So they're burning trees, American trees. We have a big forest industry sending shiploads of pellets to England to burn for electricity. I think it's the stupidest thing in the world. A lot of this is federal government mismanagement. It burns. Anyway, so that's pretty much about forest fires. Okay, how about sea ice? Al Gore. We're not going to have any ice in the Arctic. 2000, David Viner. Children aren't going to know what snow is. So here's sea ice. And you can see here's the top line is, that's a global on top, Arctic, and then Antarctic. So you can see in the last 10 years or whatever, it's gone down a little bit. At least to me, it doesn't look so alarming.
Of course, it doesn't look alarming the way you're plotting it.
The way I'm plotting
This is the plot you're showing, the second plot you're showing shows it. Making an argument from this first plot is nonsense.
Well, no, this goes back to 1979, and this is global. This is Arctic.
You can't see the forest for the trees.
No, these are the extents, sea ice extents.
The next plot.
Oh, so here, the lowest one was 2012, 2017, 2015 was the third lowest. Here's 2019. And you have the 80s average. So it's below the 80s average. So it's gone down.
By quite a bit.
Yeah, still plenty of ice in the winter.
No.
Here's Greenland. Greenland. So this is this year. This is the averages in gray. Goes down every summer and goes back up every winter. So here's what you see for the sea ice loss, and it's a lot, gigatons. So they do this in gigatons. We've lost, 4,000 gigatons. But if you do it from 0 to what it is, that's what it looks like. So you can lose this much. It's going to take you 2,000 years to get rid of the ice in Greenland at the rate we're going today. So it did shrink. It shrank. But this is the reality. You can show a graph like this, it looks like, the world's coming to an end. So this is pretty scary, right? The Greenland seas have been hitherto covered in ice in the last 2 years and entirely disappeared. I mean, we know it's not recent because it's been ice in Greenland for a while. So when was this quote? 1817. So just another example, doesn't seem to be related to CO2. Yeah, so Greenland's had ice, had no ice. It used to be called Greenland because the Vikings put a settlement there. They actually grew crops. I don't know what crops you can grow today unless you have a greenhouse. But it seems the world changes with or without people. There weren't that many people in the world in 1817. I don't know, just more records, polar bears. This was the big scare, polar bears. National Geographic showed a starving polar bear caused by climate change. They later apologized. Here's the global population size. It's been going up. You know, polar bears can swim 100 miles in open ocean. They're really, really good swimmers. So why did polar bear population go up? Because Canada outlawed hunting polar bears. They outlawed hunting them and killing them, so the population went up. Pretty cool. Amazing what policies can do. I'm going to skip this. How about crop failures? We hear that, you know, with a warming Earth, we're going to have terrible crop failures and millions of people will die. What are the trends? CO2 is plant food. So the more CO2 you have, the more you could actually grow, and you can feed more people. Okay, so this is Our World in Data. By the way, you can go to Our World in Data. They have so much information, so much data on all kinds of stuff. It's one of the best sites if you want to look at information. They get it from the UN and from the US government and from European governments. It's a really, really nice site. They have a lot on. I just did an example of cereal yields. So, and you know, you can look at what were the reasons that crop yields went up so much. You know, plant breeding, seed disinfection so they don't die, herbicides, technology, cereal price, trade liberalization, fertilizer. We're growing more and more and more. And what yield means is you don't need so much land. You can grow so much more. So this is from 1 to 6 or 1 to 5 times as much cereal in the same land. It means you need less land. And in fact, the land use for crops has gone down because the yields have gone up so much. So much for droughts and all this stuff. We're not going to be able to feed people. Here's meat production.
Shelly, that's a false argument to a certain extent, because you're supplanting water and drought and all that stuff with the use of chemicals that have other side effects in the environment. So it's really not as simple as the graph shows. It's a very complex argument. You're supplanting one pollutant, if you will, with another.
Well, CO2 is not a pollutant, but
I just used it as a phrase. I won't characterize it as a pollutant.
Yeah. Otherwise, we'd have to kill all you guys because you breathe out CO2. If it's a pollutant, we'll have to get rid of humanity and animals because
that's an option.
Anyway, yeah, no, there are a lot of reasons. There's, you know, hybridization causes greater yields. There's so many reasons to cause greater yields. Roundup gets rid of, you know, the things that steal water and stuff from the soil. So, but we're able to do this, and CO2 is certainly helping this factor. Crops, meat production has gone up. Aquaculture, you know, we're not fishing so much from the ocean, wild fishing, although I prefer to buy wild fish. But you can look at, you know, to feed billions of people, you need to do aquaculture. So food production keeps going up, How about famine? Again, Our World in Data. 1870s, 20 million people died. 1890s, 1920s, 30s. Soviet Union, they starved the people in the Ukraine because there wasn't enough crops to go around. That was really bad then. But not so much anymore. Annual rate of people dying due to global famine per decade. So since 1970, things have gotten pretty good. You know, we know CO2 is plant food. NASA, with their satellites, because they can go back in time and look at the Earth from satellites, they believe that 70% of the greening is because of CO2 of the world. And it turns out that plants with more CO2, there's something called a stoma in a plant leaf, and there have been experiments that show that. So the more CO2 there is, the smaller the stoma has to be. What the stoma is it's kind of the lungs of the plant. It breathes in CO2 and it breathes out moisture. So as the stoma gets smaller, there's less moisture lost by the plant. So it becomes more water efficient as well. So it's pretty interesting science for CO2. And we know that greenhouses pump, I don't know, 200-300 parts per million CO2 in the greenhouse because it is plant food.
By the way, the stoma is actually open and closed.
Yeah, yeah. But they are much more efficient with more CO2 and they lose less moisture, which is important in a desert area. You don't have that much moisture to begin with. You don't want to lose that.
That's how the plants are more efficient because of this dynamic effect that they have with regulating H2O and CO2.
Okay, Manhattan will be underwater. Eventually, it might be underwater. But the recorded rise is 1.5 millimeters per year. Venice is not sinking because of the water. It's sinking because of the weight on the little islands that they have. Let's look at the history of sea level. So we have satellites. Satellites are pretty amazing. And since 1993, the satellite's been measuring the sea level. And guess what? It's linear. It's not following the CO2 curve. It's linear. Now, we know there are reasons why the water level rises. We know there's some ice melt. We know that when it's hot, the water expands and gets bigger. But it seems to be pretty consistent from how 1995 for satellites. How about if we look at historical? From 1900, people have been measuring tide levels in harbors. And it's also pretty much the same consistent stuff. So I think we can be prepared. We have time to keep Manhattan from sinking 1.5 millimeters a year. We can probably do what Venice is trying to do with, tidal control and stuff like that. I mean, we have technology that can do this, but it doesn't seem to correlate with CO2. So it's there. We know water rises. It's been rising a long time. Nobody argues that. But it's been rising for a long time. It's pretty linear. And just some examples they have, first year when they started measuring Seavey Island in May 1926 and so on and so forth. And you could see, records over time. I was told that we're going to have more droughts. This is just an example of Sierra snowfall since 1916 when they started measuring it. Pretty flat. Skip this. Annual median precipitation from 1900. This went down a little bit. People are pretty flat. Charleston went up, Jacksonville went up. So this is the U.S. 100 years of precipitation. Any questions? We talked about drought, food, a lot of important stuff. Can we feed people? Are we going to run out of food? Seems like there'll be plenty of food for everybody, as long as we can get diesel fuel for the truck to bring it to Stop and Shop. Any thoughts about that? All right. Which is more deadly, hot or cold? Turns out cold is a lot more deadly. And there are medical reasons. Half of cold-related deaths. Your blood gets thicker when you go out in the cold. They always say warm up before you shovel because a lot of people get heart attacks from shoveling in the cold. Not to mention falling. My brother-in-law fell down on the ice and broke his collarbone. I mean, there's all kinds of stuff that can happen with the cold. But all I hear is that if it gets too hot, people are going to die like crazy. So UK, the authors did a test. Because it got warmer, the number of people that died shrank. Deaths due to cold weather fell dramatically by thousands of people in England because it warmed up a little bit. In fact, they're growing grapes. I'm into wine, and you can get sparkling wine from England that's pretty good. It did warm up a little bit in England. Also, if we start tripling the price of electricity, people are going to be very cold in their own homes, especially poor people. So that's just a thought. If we want to go totally green and have 3 or 4 times the price of electricity with brownouts, it's going to be bad for people in northern climates. I don't know how they're going to stay warm. Anyway, so just an example. Cold kills more than heat. So warming up a little bit is not so bad. Okay, how do you deal with skeptics? So I guess I'm considered a skeptic. Refuse to debate skeptics. So far, whatever few debates that have been, the skeptics have typically won all the debates. Okay, so let's look. We talked about, scientific papers, facts. Let's talk about changing the facts. NOAA measurement sites reporting warming trends for 50 years. I like the second one. Humans are heating up the thermostats, the thermometers. Actually, the correct answer is all the above. Yeah, the Earth is warming. But NOAA does magic with thermometers. All right, so I just wanted to share, we have land stations. The US had hundreds of land stations that NOAA used to measure temperature in the United States. Here's the climate station in Lampasas, Texas. There's a little satellite dish to record on the climate. There's a little measuring device. You guys notice anything interesting about that temperature station? This thing up here?
It's right next to a building.
This thing right here? Yeah. So you wonder why the US land-based temperature has been going up. So here's just some examples. These are all
That's just one data point, right?
That's just one. Land-based temperatures. So Cornwall, Vermont, since 1900, it went up. Look, it went up. Steamboat Springs seems to have gone down. Ohio went up recently. Berkeley went up a lot. I wonder why. From 1890, it went up a lot. Do you think there's a bunch of sidewalks that were put in place? Here's a good one that I like to see. Central Park, boy, that's been going up since before the Industrial Revolution, 1840. Look at this. Before Edison made his first electric plant. But how about
There was no Central Park for a good part of what you're showing.
Yeah.
You're cherry picking.
I'm not cherry picking. I'm just giving examples of how something called the heat island effect. If you have a thermometer in the same place and you start pouring concrete and put cars there and
Shelly, I have to agree. You are cherry picking.
I am cherry picking, but this is reality. This is reality. Heat island effect. This is Antarctic temperature.
Cherry picking is not reality.
Oh, it is reality. Okay, so surface stations in 2012. So these are the classes of surface station. Class 1, in a grassy area, far from bodies of water, people 100 meters away. Class 2, Class 3, an error greater than 1 degree C. Class 4, Class 5. Errors greater than 5 degrees C. These are land-based temperature sensors. The majority of sensors match which class? Which class do you think you would do? Do you think you want class 1, grass, low vegetation, no people? Or class 4 and 5? So this is NOAA's temperatures, land-based temperature sensors. Class 4, 64%, class 5, 66.2%. The ones with a little bit of error is only 8%. So this is how NOAA measures temperature. This is how it should be. This is what a temperature station should look like. Nobody's around, no air conditioners, no people, and here's the temperature. Hey, it's gone up a little bit. And here's another one. Next to the cell tower parking lot, here's the temperature sensor, air conditioners. And that's Marysville. Boy, look at that. The world is going to be boiling pretty soon. Again, this is cherry picked, just showing you how temperature sensors affect temperature. And then you have satellite measurements. Satellite measurements can measure the whole world, lower atmosphere, And look, it's gone up a little bit. In the last 40 years, it's gone up, I don't know, half a degree C. 0.44, July 2020, 0.44. So yeah, the Earth is warming. We all know that. We all agree. Not that much. So my whole point of this is we shouldn't be alarmist and destroy the U.S. economy over something that actually has some goodness to it. Plant food, fewer people dying, not so bad, not so bad. This is, from the U.S. government. They do this.
Yeah, I do have kind of a comment.
Sure.
To go back to the chart. Like for 1 year, you've got one temperature. And that is averaged over, the deserts and the Arctic and night and day and the oceans and land. It's a lot of calculation goes into that. A lot of fudge factors actually go into that calculation. That's all I want to point out.
You know what the NOAA does? I'll show you fudge factors that NOAA does.
Yeah.
But the satellite data is just the raw data. This is just the scrunched up raw data.
Yeah, well, I mean, one fudge factor that I'm aware of is that temperatures of over water are treated differently, typically in the data than over land. And what is that fudge factor, and where does it come from? Where is it derived? It's complicated.
Yeah.
Hey, Ken, not to disparage your point, but if the fudge factors are consistent across a data set, doesn't that mean the data is still comparable?
It's complicated. Let's just make that point.
Fair enough.
Okay.
Okay, so how about remember I showed you all those terrible temperature sites? So now NOAA was so embarrassed that they ended up getting rid of 2/3 of their temperature data sites, because some of them were like at LaGuardia Airport, which had a couple of biplanes when they started and now have nonstop jet engines. So they came up with 114 pristinely maintained stations in the 48 states, far away from urban and land impacts. Take a look at the temperature since 2005. So this is land-based temperature, and they're all class 1 sites, not the terrible class 5 and 4 sites, class 1 sites. Again, data right from NOAA. That's why we're global warming, global climate change instead of global warming. So yeah, cities are getting hotter. You know what causes cities to get hotter is all that concrete absorbs sunlight, and then it spits it back out at night. Cities have definitely gotten hotter. But guess what? Farmlands and other stuff don't seem to have that issue. So there's even question about, we know the satellites don't lie, and they show a rise in temperature. But here's a case of land. Okay, so NASA and NOAA were not happy with Hansen. Remember I said Hansen said in 1999 there was global cooling? So NASA sends out, charts. Here's their 1999 chart. Remember, this was the Great Depression. We had the heat waves. Look what they did in 2016. Here it's a 1.5 degrees. Here it's 1.2 degrees. Doesn't this chart look better? Look, the chart's going up, and this one, what happened in the 1930s? So this is called fudging your way to get to your political point that you like. So monthly average.
Can we just stop right? I have a question. We've heard a lot in the last hour and 25 minutes of your point. What do you think is the cause of all of these, what appear to be sort of almost a coordinated conspiracy for global warming, for the stating the case for global? What would NASA have to gain by coming out with these kinds of results?
I think there are two things. One is money, and the other is politics. If the world is going to end, you're going to throw as much money as you can to prevent the Earth from ending. So the biggest alarm you can make, the more money is going to come your way. So I think number one is money. And number two is politics. People don't like, they don't like the fact that we're living well. They want to get rid of gas and oil and all this other stuff. So those are the two reasons. I think the biggest reason is money, to be honest. You don't get money. If somebody says, hey, things are okay, we're actually going to do better, nobody's going to give them any money. I can prove to you that the earth is going to melt. I have models that show you that. You're going to get money for that. So I think that's the biggest reason. That's my personal opinion, and that's what what I see. So much money.
So people want into climate change to get rich?
No, they don't go into climate change to get rich, but if they're an alarmist, they'll get money thrown, they can ask for money and they'll get money. You don't get rich. Nobody gets rich doing this. These professors don't get rich doing this.
Shelley, just in terms of what's going on, it looks like we have about a little less than 10 minutes. How much more do you have? Because I want to give people a chance to talk about this stuff. I think they've raised a lot of issues, and certainly climate is it's a benign topic. People don't have strong opinions, and we give them a chance to at least settle out and have a discussion, a civilized discussion about this
Sure.
afterwards.
Yeah, I just there's something called ClimateGate. That was the East Anglia University in England. They were making stuff up. And here's another example. This is a 2009.
Wait, I disagree with that statement that they were making stuff up. They were saying that they wanted to be a little cautious about what they said because people would grab onto some things. There was no evidence, and nothing they said was that they were making things up.
Okay. They don't share their data, Carl. They refuse to share their data. Again, this is not scientific not to share your data. Just another example of let's adjust the temperature so it looks better. Just one more example of hiding the past. IPCC in 1995 showed the medieval warming period. Doesn't look so scary. They took it out later, 1998. They basically lied about the temperature. I'm just saying that, again, IPCC is the United Nations. They're a very political organization. They don't do it for money. They do it for politics because they want U.S. to pay for other countries or whatever reason. But if you hide the past, you can make things look different. And I showed the model. All right, so just a couple of more things. Let me see if I can do some stuff. All right, so it's a cash cow, basically.
There's been a lot of comments, and people have some strong opinions. I'd like everybody to have a chance to chime in and talk about this.
Yes, I think there are two factors that probably need to be added. One is modern communications. I don't think in the 1930s New York would have heard there's a hurricane in West Texas or there's a fire in California. Today, you have that immediately. And so the perception is there's much more going on, and it's all due to climate change. Secondly, the fact is humans do affect climate because they live in places that they shouldn't have. In 1918, there were forest fires, gigantic forest fires. In fact, the reason why we have a Forest Service created was because of this gigantic forest fire that was out west. Nobody knew about it because there were no houses nearby. Nobody died except for firefighters started putting it out. Today, we have, in California especially, housing around beautiful scenery, and the beautiful scenery is inside forests. And when there's a forest fires, you have houses burning. So, you have to factor in more people on Earth and also communications that feed this frenzy of alarmist climate change. I agree that, I'm a skeptic. Yes, climate is changing, but it is due not to blame everything on CO2. it's crazy because, you know, it's like Indians dancing for rain, and the actual is, well, if you dance and there's rains, say, aha, we succeeded. If you don't dance and don't get rain, saying, well, you didn't dance hard enough. And I think spending all this money trying to beat the dead horse on CO2, whereas there are other problems, bigger problems that we should address. Yes, Florida is having issues and they need to address it, but the addressing is not CO2. Addressing is how do you stop floods and how do you prevent seawater coming into the cities? That's my comment.
Can I ask a question, Shelly?
Sure.
Is climate changing? In other words, is the temperature of the Earth going up?
It has been recently. Doesn't prevent.
Why is that?
Why is that?
Yes.
My belief is solar activity.
What about the ozone layer? And what about the hole over the Antarctic? It's now beginning to close, but supposedly, at least way back when I remember Al Gore at the first part of it, problem was you're getting this ozone layer was having a great big hole over the Antarctic, allowing the heat from the sun to enter the Earth, and the ozone was not absorbing it, and not enough of the heat was being radiated back out. Now, I'm not sure if that's true. I don't know what the historical record of the ozone layer is, but I'm wondering about how that's having the effect on that.
All I know is that Antarctic ice keeps growing in recent years.
No, I don't think that's true.
Yeah, it has. The sea ice has been growing, and I can send you charts showing the sea ice has been growing.
Wait a minute. What about all that ice that's now cracking off and going into the sea from the Antarctic?
You know, the ice, growing glaciers have ice drop into the ocean. It's called calving.
Yeah.
That's from growing glaciers. So it happens. Ice, these ice things fall down. We'll see what happens. We've had big pieces of ice chunks come off of Antarctica.
Okay, but what about the long term? What about the long-term measurements? Have there been any long-term measurements, say more than 100 years, about?
Probably not, because the explorers, only came there 100 years ago. We do have satellites now, and the satellites showing a greater extent. But we know the water is rising, the oceans are rising, and a lot of that's due to, melting glaciers and ice coming off Antarctic and the Arctic. So we know the water is rising for a variety of reasons. So that has to be some, but again, it's nothing to be alarmed about. Holland is underwater. They figured out how to take care of things being underwater. So those are things we can take care of without, destroying mankind. So my whole presentation saying we shouldn't be alarmed, we shouldn't spend trillions of dollars on something that's not alarming. And I try to explain that to you. The Antarctic is growing. The Arctic seems to be decreasing a little bit in terms of ice, but the Antarctic seems to be growing. So, we'll see. It's going to take, like I said, Greenland could melt the way it is, and it's 2,000 years before the ice disappeared. But in 1817, there was no ice around Greenland. Again, there are a lot of natural things that happen that we don't understand. That's why IPCC hasn't modeled the solar cycles in their models. They just don't understand it. It's so complicated. You can't get a good weather forecast for tomorrow, let alone a climate forecast for 100 years.
Shelly?
Sure.
So you've said that you agree that the Earth is warming, right?
Yeah, it's a recent trend.
Okay. And you attribute this to solar intensity? Solar cycles?
A bunch of factors. I mean, I stated that.
But your charts show a low point right now in solar activity.
Well, I also showed that our Earth-based measurements in the United States, the temperature hasn't been going up. And I showed that we're going into a lower solar cycle. In fact, one of the things that CERN did, all the atom colliders in CERN, they measured the fact that cosmic rays cause clouds to form. So we know that clouds reflect sunlight. They also absorb heat, but they reflect sunlight. The more clouds you have, the less solar radiation falls in the earth. So
what's missing is a chart that shows, the temperature change and the correlation with solar activity. I haven't seen that in your presentation.
I did. We did show the solar cycles were up in the early 2000s, and the temperature went up then. So
I remember seeing a chart that says that the solar intensity is at a low point.
Yeah.
Well, the low point was the Maunder minimum, and that was the last ice age. We had mini ice age. We had low, again, using ice cores and stuff. We had low solar activity. People have been measuring sunspots and stuff for a long time, but we know people were ice skating on the Thames in the Little Ice Age, and certainly since the Little Ice Age, the world temperature has gone up, which is a good thing, as far as I'm concerned. So it goes up and down.
There's a website, for SOHO, SOHO. That's the satellite that's been monitoring the sun for the last 20, 30 years. As a matter of fact, Hanscom Air Force Base, the research lab there did quite a bit, has something on there too. But anyway, the point is, what you mentioned about the changes in the sun's radiation, that website used to tell you sometimes that some of this is going to affect the temperature and the Earth's atmosphere. So that's another data point if you guys want to look it up. It's quite interesting, actually. It's amazing that satellite is still around.
Yeah, it's good actually, because you have a longer record of all this stuff.
Shelly, one question also, which is kind of general, I would say, topic. You showed a slide and you mentioned that there were giant ferns in the Precambrian period when there was plenty of CO2, which eventually may have become today's coal and oil. And I understand right now the changes are not as acute as it took us from that point to today.
Did you freeze?
But if you actually continue to have some of the policies that were promulgated a couple of administrations ago, when some people said, burn, baby, burn, referring both to coal and oil, we could potentially someday, remote into the future, burn all of that stuff that was sequestered by Mother Nature so nicely. Would that be a wise thing to do? Would that be a good goal to working towards, burning more and more of the fossil fuels?
Yeah, no, like I said earlier, I think nuclear is the way to go. That would give us a great baseline and charge electric cars and stuff like that. But I think we're stuck with oil for the next 100 years. There are no batteries for trucks. You can't get a container ship that uses batteries. I mean, or solar cells on top of the ship. I think you look at electric generation. We could do electric generation, but I think the world needs to use oil for a long time.
No, I mean if we eventually have a nice solution for the nuclear energy, that will answer a lot of questions in also generating synthetic fuel like burning hydrogen that will dissociate, so that in fact airplanes can continue burning with today's engines and not rely on cells or wind turbines that they will carry. Okay, that would be
hydrogen would make a great fuel. In fact, there's a hydrogen depot in Braintree. If you had a hydrogen car, you drive to Braintree and you can fill it up with hydrogen.
No, but until then, I think until then we can be actually relying more and more on some of the turbines on ridges, not next door to your house or anybody else's house, and also solar cells during the day. Or we can pump water from the sea up during the day and then let it flow down and run turbines during the night. There are many things like that. I mean, if one was willing to create some lakes, 5 lakes in the world in the middle of deserts, that were about the size of Vermont, okay, 5 such lakes in the middle of famous deserts, you could produce more than twice the power that we're consuming today by flowing the water down during the night. There was a feasibility study like that.
Yeah, there's also,
It's pie in the sky, but it's there.
I think we should dam up the Mediterranean and put generators on either end. So the river water flows to the Mediterranean, the level rises, maybe Sicily will be underwater a little bit, who cares? And then it can flow to the Atlantic and the Indian Ocean and generate electricity. By the way, that proposal was put out in 1920.
I wouldn't like the Greek islands to go to underwater, you know?
Nothing personal, right?
Nothing personal at all.
Hey, if we had enough nuclear, we can generate all the hydrogen we wanted. Electrolysis. There you go. Any other thoughts?
Yeah, we'll put the nuclear waste in your backyard.
Sure. As long as we can dig a hole 1,000 feet deep, I don't mind.
Yeah, that's
1,000 feet's not going to help.
Yeah, that's the only problem with nuclear is the waste, because down in Georgia, right? Oh no, my presentation there, they're building like mad these nuclear power plants for the area, but the public relation is zero. They don't tell you a damn thing about it up here. You know,
the French have a solution. They turn the nuclear waste into glass. They have a glassification thing, and they're getting rid of the nuclear plants for some reason. I don't get it. But they had a really good way to do something with the spent fuel.
Yeah, you don't want to talk about the environmental impact of creating glass out of nuclear fuel. That's a whole long another discussion.
How about the environmental impact of arsenic and solar cells when they break down? What do you do with the arsenic and solar cells?
You have arsenic anyway. Just
yeah, we can go through.
What's the difference? It's all arsenic. It's all over the world. What difference does it make?
Oh, there's other cadmium, arsenic, there are heavy metals, there are all kinds of stuff in silicon solar cells.
That's right, all over the world. So what?
You can't recycle.
Oh yeah, if you're going to worry about that, worry about your iPhones and your laptops and stuff like that have probably even more arsenic in them.
You guys say arsenic.
And all of these other metals.
And the problem with Shelly, in my opinion, the problem with what you're saying is that, there's no simple answer. There's no black and white here. What you do is you end up trading problems. You solve one problem and you create another one, or at least create an issue that we don't have an answer for. And those kinds of things just, it's a circular argument. It's like a circular firing line.
No, Pete, you're absolutely right. That, Peter, when I was in high school, the physics and chemistry teachers, they would say, we're in a cycle of life, the land, the sea, and the air. And everything is related. Everything you do to one of those three components affects something else. So, when you talk about global warming, it's really, what pieces of the puzzle and what do you do about it and how does it affect the rest of the puzzle in the globe? So what I'm really talking about is, like overfishing, does more damage than you realize. Like the salmon, they were, from fertilization, to all this other stuff. So I think all of us are really integrated. We're all systems integration engineers. That's what you got to be to think about what's going on.
Shelley?
That's a great point, Dave, but the cure shouldn't be worse than the disease.
Shelley, do you think that climate warming is going to continue, or do you think it's going to cool?
I don't know. According to the CO2 8% or whatever, it could go up a little more, but I think it's by solar cycles as much as anything else. And from what NASA is saying, we're going to have a low solar period for the next so many years. I certainly hope it doesn't turn into a Maunder minimum, where we would cool off by 2 degrees C or 3 degrees C or whatever. That'd be devastating for agriculture and plant life and people life and animal life. I don't know. The signs are the solar cycles are getting lower. So we could be going into a cooling system, but I don't know yet. We'll see over the next 5 years, basically. But the solar cycles have changed. It's gotten much lower intensity from the sun. So we'll see what happens. I don't want to predict. I'm hopeful it won't get cold.
There's two things for life. Since I can't go anywhere and I'm retired, I've been watching a lot of stuff on TV, the Science Channel and National Geographic and all this other stuff, and space. One of the things about planets, getting the juice, the sweet spot, you can have a sweet spot, but the planet itself has to have some internal mechanism to generate heat, which we have. And I'm just wondering what the core and the heat that we generate internally to the planet, that with the sun is what gives us life.
Yeah,
So,
I don't know how much self-generated heat. But we know the core is molten and it's pretty hot. A lot of pressure down there.
yeah, neither do I. That's why I bring it up. That at least we may get a little colder, but I don't know how cold.
Yeah, I think unless you're in Iceland, which heats itself, via volcanic activity, I think people are going to be pretty cold. So better a little warm than a little cold. But it's if you look at that history chart with the CO2 8,000 parts per million, the Earth climate temperature range was narrow. It's pretty incredible over few millions of years that the Earth hasn't melted down, gotten too hot, gotten too cold. It's just incredible. We're in a self-regulating, we should all bow down to Mother Earth for giving us a planet that creates life and is self-regulating. It's pretty amazing. No matter what the dinosaurs did or what the people did, we're still operating within that range. So anybody that says we're going to melt down, I think they're just
I agree with you. I think it's the man upstairs, Thank God.
Maybe, we're all digital computers. You look at our DNA, it's, it's those letters in a sequence. And that's pretty amazing too. If you think about, how DNA is made and how it can't be done. It's just bizarre. It can't be done randomly. I don't know. At least from people, we're only 150,000 or 50,000 years old. All the stuff that's been done in the last 50,000 years, it's pretty incredible. So if you don't believe in God, I think that's a reason to believe in God too.
Shelly, I think that's a good place where we can sort of wrap up, or this thing can go on forever.
Okay.
So on behalf of the group, I want to thank you. I think we had a really interesting and stimulating discussion. We only had a few people that disagreed. Everybody was all in agreement and we were all on the same page. So that's a good thing. More importantly, the factually, I think there is a lot of data. You presented one perspective and that was appreciated. I think it's clear there are many other perspectives, and I think it's up to all of us to try to do the investigating and learning that we can, to bring different points of view together, and hopefully we'll find a solution to this problem in our lifetimes that keeps everybody going. Thank you all so much. We'll see you next week. Take care.
Thank you.